Hello to my students. This is your probability and statistics subject. Today I am going to explain about Poisson probability distribution. This distribution was introduced by a French mathematician S.D. Poisson. This was invented by the Poisson with the rare distribution of rare events, that is the events whose probability of occurrence is very small and the number of trials are large. For example, you can take an experiment, and whenever you do an experiment, that experiment may be any number of trials to get the success. But whenever we do an experiment, that may get an outcome, that is success or failure. So consider this success as P and this failure as Q. So whenever you are taking that number of trials as n, and that number is small, then that comes for binomial distribution, so that we discussed in the previous class. Whenever this number of trials are large, then that consider for this Poisson distribution. So this is the small difference of this binomial and Poisson distribution. So you can easily identify according to the number of trials. If number of trials are small, and that is comes for binomial distribution. If n number of trials as large, that number may be as 100 or more than that. That is related to the Poisson distribution. And also a small indication to find whether it is related to which type of distribution is, that is a probability of success, that is P, is small. So according to this N and P, we can define that is which type of distribution. So already we discussed that binomial distribution is related to the discrete variable, and this Poisson distribution is also related to the same discrete variable. Why? Because this number we are taking for this successes are counting numbers, that is from x is equal to 0, 1, 2, 3 like that. So this counting related to the discrete variable. So whenever that is not related to the counting and that is related to the interval type, that is comes for continuous variable. That is already previous lecture. Next, coming to this one is as rare distribution of rare events. For this you can take one example, that is the number of printing mistakes per page in a large text is a rare event, and its probability is very small. You can know in a page the number of mistakes are very less, so you can consider that probability is very small. But when compared to next large text, that means the total pages in a text, that mistakes that total number of mistakes are high. So for this example, you are clear about the why it invented for the Poisson distribution. Now coming to the next point, that is properties. So properties of this distribution are, the first one is whenever you consider for this range of the variable is from 0 to infinity. Why? Because this is the countable one, and that is from 0 to infinity. The next, coming to the mean. Second one is mean. Mean, already you know about the formula. Lambda is equal to NP. That is related to the number of trials, and P is related to the probability of success. So the product of this NP is the mean of that distribution, and that mean is equal to the variance also. And in this you can call this lambda as parameter of Poisson distribution. So is that clear up to this? Now the basic definition for this Poisson distribution is the probability of this distribution can be related as the random variable x is said to be a Poisson distribution if it assumes only the negative values, and the probability density function is given as, that is, probability of x successes is p of x is equal to small x, and that is equal to e power minus lambda into lambda power x by x factorial. And this will be the formula for this getting the rare events probability. Now in this case, the lambda, already you know, lambda is a parameter of Poisson distribution, and that formula is NP, and x is the number of required successes, and lambda always be the positive. There should not be negative values for this lambda. That's all about this introduction of Poisson distribution. Have a nice day.